Hello, today we're going to be talking about the most common functional groups that you might see in biology. Functional groups are groups of specific atoms bound in a certain arrangement that give a compound certain physical and chemical characteristics. It can be said that functional groups give that molecule its function, and this is because each functional group can bond, dissolve, or undergo specific reactions that will give the molecule a function. Now, each functional group, for example, alkanes, will act similarly regardless of what compound it is attached to. And this is because they will all undergo similar reactions and have similar behaviors. Now, in this slide are molecules that contain each functional group. We will come back to this in just a few minutes, but for right now, we're going to give a brief explanation of 12 functional groups. So let's start with alkanes. Alkanes are anything of saturated hydrocarbons. Now, a saturated hydrocarbon means that it's just a chain of hydrogens and carbons. And saturated means that there are no double bonds in the hydrocarbon. So it is saturated with the maximum amount of hydrogens possible. You can follow the formula for alkanes here. It is the number of carbons, and then to figure out the number of hydrogens, it is the number of carbons times 2 plus 2. Now, alkanes are nonpolar. This means that there is no imbalance in electronegativity between the hydrogens and the carbons, and so therefore it is more stable in hydrophobic environments. Alkenes and alkynes, on the other hand, are very similar to alkanes. Alkenes and alkynes are both unsaturated hydrocarbons. They are both nonpolar as well, but the difference between the two is that alkenes form a double bond, while alkanes form a triple bond. Next is ethers. Ethers are comprised of an oxygen atom bound to two alkyl groups. To remember this easily, ether structure is similar to water, but instead of two hydrogens attached, they are replaced by alkyl groups. Some properties of ethers are that it cannot form hydrogen bonds, and this is because the oxygen is not bound to a hydrogen, which is required for hydrogen bonding. Ethers are slightly polar, they serve as a good base, and so they react with acids. They are relatively unreactive, and so as a result are useful as solvents for fats, oils, and hydrocarbons. Next is aldehydes and ketones. They are both two different types of functional groups, but just have one difference between the two. An aldehyde is Sorry, my mouse is freezing. An aldehyde is an organic compound that contains a carbonyl, which is the C-double-O bond, with the central carbon bounded to a hydrogen and an R group. Now, carbonyl is a carbon double bonded to an oxygen, and an R group is some type of hydrocarbon bond. Next is ketones. Ketones, on the other hand, are a carbonyl group with the central carbon bonded to two R groups that are different. The difference between an aldehyde and a ketone is that there is a hydrogen that's bound to the carbon in an aldehyde. Both these functional groups partake in oxidative reactions in which they become oxidized to the corresponding carboxylic acid. Next is alcohols. The structure of alcohols is also very similar to water. It is an oxygen bound to one hydrogen and an R group. Due to the presence of the OH, alcohols can hydrogen bond, and this leads to a higher boiling point compared to their parent alkanes. Alcohols are polar in nature, and this is attributed to the difference in electronegativity between the carbon and the oxygen atoms. Alcohols often cannot leave the molecule on their own, so they are a poor leaving group. And you will see more of that in organic chemistry. Esters are a functional group produced from the condensation of an alcohol and a carboxylic acid. They are characterized by a carbon bound to three other atoms. A single bond to a carbon, so this R group, a carbonyl, this double bond to oxygen, and then another R group, or another oxygen that is bound to an R group. You can see the structure here. Esters have low polarity and they are generally involved in nucleophilic reactions. Next is carboxylic acid. Carboxylic acid are organic compounds that contain a carbon atom that participates in both a hydroxyl and carbonyl function group. A hydroxyl group is just an OH group. This is a major precursor to make other compounds like esters, aldehydes, and ketones. Carboxylic acids can partake in hydrogen bonding, and they can be a hydrogen acceptor or donor, which stabilizes them, giving them a higher boiling point. This gives them the ability to form resonance structures. Quickly, we will discuss nitriles. This is an organic compound containing a cyano functional group. This is a carbon triple bonded to a nitrogen. This group is called a cyano group or a nitrile group. These names are interchangeable. An amide is an organic functional group with a carbonyl bonded to a nitrogen and another R group. They are a very similar structure to esters, but instead of a second oxygen bound, a nitrogen replaces it. In this picture of an amide, the nitrogen is attached to two hydrogens, but it can also contain an R group. Lastly, amines are a compound characterized by the presence of a nitrogen atom with a lone pair of electrons and 3 substituents. Now in this picture, there are 3 different R groups, but it doesn't necessarily need to be hydrocarbons attached. They can all be hydrogens. They are basic compounds. They can hydrogen bond as well, making them soluble in water. Now, amines normally are a nitrogen bound to 3 substituents, but it can bind a 4th substituent instead of the lone pairs, leaving a positive charge on the nitrogen atom. Okay, so below is an example of each of the functional groups. I tried to choose some of the most common compounds, but they are just here for reference so you can see the functional groups in a compound. So we have methane, ethane, ethine, phenol, formaldehyde, acetone, ethanol, ethyl acetate, acetic acid, methyl cyanide, propionamide, and methanamide. To wrap up, functional groups are extremely important. For example, specific amino acids have certain functional groups, allowing it to bond and react with other amino acids. This in turn helps a protein fold a specific way, giving that protein a function. Functional groups remind me a lot of personality traits in humans, because a personality is what makes up a person, just like how a functional group gives a compound its properties. Some personalities don't work well with each other, and vice versa. So I hope this video was helpful to become familiar with some of the common functional groups and to understand some of their individual properties.